Hello everyone and welcome to Ocean Cadence. In today's video, we'll be undertaking the topic of quick closing valves, that is, explaining how the design and the operational part of quick closing valve goes about, and also later on explaining how the triggering and the operation of the quick closing valve happens through a circuit or a line diagram. So let us start. As the name implies, quick closing valves are valves that are meant or designed in such a way that under certain circumstances of emergency, these valves are desired to close in an instant. So basically, the time that we have to spend in manually closing a valve under any situation is overcome with the help of quick closing valves. So what it essentially also means is that it does not need human intervention to individually go to these valves at the local area or the place where they are installed and shut them manually and eliminate the risk under emergency situations that is associated with this entire action and also the time that would be taken to carry this out. Now, first of all, what can be the purpose of these valves? So let us imagine a situation that there is a fire in the engine room and the source of fire is being fueled by the storage tanks, or let's say the service tanks that we have within the engine room. Or maybe if the source is not fueled by this, it might be in the fire, that is the fire might be in the vicinity of these tanks. So there is always an imminent risk that the fire can either grow in size or it can keep going because there is abundant fuel and other resources that are flammable in nature within the engine room. So what we essentially want is to isolate the lines or cut off the supply from these resources, that is the tanks and the pipes through which this fuel is flowing, and make sure they are isolated properly. So in that case, what we would want is that is the outlet line basically, which is going into the supply system from these tanks. So now let us, for example, say the outlet valve of a cylinder oil tank or a lube oil tank. Basically all those tanks which have bulk quantity of fuel and lubes that are flammable in nature, and also the waste oil tanks, because again that is also a highly combustible mixture which is present in the tank. So we would want these tanks to be automatically isolated on their outlet lines, that is the inlet to the main system. So what we end up doing is that we end up installing quick closing valves on these lines. Now, these quick closing valves, first of all, as almost everybody out of us knows, are remotely operated. So what they would necessarily require is that in addition to the normal valve mechanism, they would require an external actuation. This actuation can be of different types, per se electrical, hydraulic or pneumatic. But on a merchant ship, what you would generally find is the hydraulic or the pneumatic type. Because of the lesser sophistication of the design, it is very easier to test and carry out maintenance on these designs, and also it is of a lesser cost occurring factor. So basically what happens is that it becomes easier to change parts or change valves and easier to order spare parts also later on. Out of this, it is the pneumatic one that you would normally encounter having the most cumbersome network, because it depends on the flow of the air and how the actuation happens, and that is why we are taking that particular design under consideration over here. So now, instead of wasting our time on the normal construction of a valve, because almost everybody of us knows about the stem, valve seat, valve disc, spring, wheel, etc. So there is not much focus that we are going to present on it, but rather we would focus upon, first of all, the actuator and the external actions that happen. So now imagine that your valve is in a situation where it is fully open. Then at the pivot part, there is a disc-like structure which protrudes outside, or a needle-like structure which protrudes outside, and this particular part is being in the open, that is in the open condition, it is being held by a latch. So now basically this particular disc that we are looking at is being held open by a latch. That is basically how in a quick closing valve we are keeping it open, that is through manual action. We have opened the disc, the spindle has moved up, and this particular disc is being held open by the latch. Now imagine another scenario where there is a air gush, or basically a certain flow of air that comes in and pushes the actuator, and this particular latch moves. So what will happen is, once this latch is displaced or once it moves, what it does is, leaving its original position, it makes the disc or this particular needle now free to move, and because this latch and this disc together were carrying the weight of the entire stem and the spindle and keeping the valve open, now as a virtue of gravity and as a virtue of its own weight and the spring tension which is there on the top side, which is very important to understand, it is free to move down. And thus, under this spring force and its natural weight and action of gravity, the valve would close. Now again, let us say that we have to reset this. So once we stop the air supply, then again this latch is open to move, and again it would come back to its original position, which is the locking position. And then again, as we go about rotating the disc, it would start lifting the valve and thus acting against the spring force which is there, and then there would come a moment that again the disc would go up at such a point where it is being held open by this particular latch. Now, another important step that we often forget is that during the resetting of the quick closing valve, we first have to close the entirety of the valve. So basically what that means is that before opening the valve with the help of rotating the disc counterclockwise, we first have to rotate it clockwise and close the valve. Why? Because it helps us in resetting the spring and the spindle mechanism by pushing it to the maximum length down, and thus making sure that first of all the valve manually is in its fully closed position, and then once everything is in order and the entire free length of the spring is extended and the retaining disc, that is the locking part or the locking needle, is also in its original position, then we start opening this valve and retain it back to its original position. So as we can see over here that in addition to the normal parts of a valve, it is also very important to pay close attention to the pneumatic actuator that is also installed with this valve, and also the latch mechanism that acts under the influence of this pneumatic actuator and helps in retaining this valve in an open position and also acts as the closing mechanism under states of emergency. So normal maintenance such as visual inspection and routine checks are carried out. Now the question would be, how are the operational check carried out? So for that we have the typical test on a monthly or a 3-monthly basis depending upon the PMS routines as to how we remotely check the operation of the quick closing valves. So now because we were dwelling upon the pneumatic type, let us consider that only. Now imagine there is an air reservoir in which we are filling the air, that is the normal daily use operational air which we are using in the engine room, and keeping it topped up. From now, imagine that you have to trigger out these quick closing valves in the form of branches. So for example, one branch might consider 3 or 4 valves, and in such a fashion there might be 4 or 5 branches. So let's say total 10, 12 or 15 QCVs that you might have to trigger. Now, what it would mean is that first of all, there would be a main valve from the tank which should always be in an open position to ensure that in case of emergency, when you are operating it from the remote location, that is the location where this entire mechanism is situated, you just have to operate the valve of the particular branch or the particular zone that you need to trigger. And then moving on to that particular zone. So now, as I originally told, that a QCV would only be triggered when an air pressure or a force of air comes in and triggers it. That means in its original state, the quick closing valve is always without air pressure. Now, why so? It is important to understand this specially because we want our quick closing valve to be a fail-safe mechanism. So, if it would have been a situation where we are always keeping the actuator triggered by the supply or the pressure of the air and thus keeping it in an open state. Now let us imagine if something untoward was to happen with the compressed air system of your ship and we were not able to maintain the pressure within the reservoir, then what it would by default mean is that as the air pressure of this tank will keep going down, the valve would then lack the external force which was pushing it open and then get triggered and automatically shut, and that is something which we do not want to happen. So that is why, as a fail-safe design philosophy, the valve is kept open without the pressure of the air. The mechanism is designed in such a way, and it is the force of the air that closes the valve. So now let us imagine that at one branch, I go and change the position of the lever and thus open the valve, and this air goes and trigger the particular branch of the QCV that we are talking about. So let's say an amalgamation of 4 or 5 valves and shuts them at once. In normal testing in the engine room, what what we do is that we keep designated people at the locations where the most critical walls are present. So let's say, for example, the service tank and as well as the cylinder lubrication tank and other tanks which are continuously under use, because you don't want your pumps to starve, because your vessel is always operational and you can't stop your vessel for testing this. So you don't want your pumps to starve. So we are always standby over there, and as soon as the operation happens, we immediately manually reset it and make sure that there is no failure of other mechanisms that happen while testing the quick closing valves. I hope that this detailed explanation helps you understand the design, the functioning, and the line and the testing part of a quick closing valve and its network. Please make sure to like and subscribe our channel so that such updates can regularly keep coming to you as we go about improving the content on our channel. Thank you.